but if you choose to find the joy of working, whatever may be your present circumstances, but if you determine for your success. Yes, you rightly heard it. ACE online platform raises you much more than what you can think. This platform provides pre-recorded and online lectures.
Very good evening to everyone. In this session, we are going to discuss the preparation strategy and some important question on the subject theory of machines and vibrations. Okay, I, faculty Muhammad Waheed at ACE Engineering Academy, will be doing this. So first, let us try to identify what are the types of question asked in the examination. First one is recall type. Recall type question means here we will be having some standard definition or some statement will be there or some standard result will be there and then some information will be given. So we have to correlate that information with the standard result or a statement. Okay. Second one is a comprehensive type question. In this one we will be seeing the question will be comprising of multiple statements. So this type of question is going to test the reading ability also. And we have to be very careful while answering this. And here you are required to choose the correct statements out of those given number of statements. Right? Next one is application. Application type means here some formula will be given and then on that formula you have to substitute the numerical values and get the answer. So it is put the values and get the answer kind of a question. Okay. And the third one would be, fourth one would be match the following. Right. Now guys, this examination will be consisting of 150 questions. Okay. And these 150 questions will be having a weightage of 150 marks, which means that each question will be carrying a weightage of 1 mark. Okay. And we have to answer this in 3 hours. Guys, this is the weightage analysis for various years. So here you can observe this subject theory of machine. It is contributing about 14 marks in the year 2015. In the year 2015 in one of these sets. In another set it has contributed about 20 marks. Similarly 21 marks and 18 marks. So guys, what I mean to say is that this subject theory of machine will be contributing about 10 to 15% of weightage. 10 to 15% of the marks will be contributed by this subject only. Okay. Now let us see what are all the topics in this subject. So first one we have guys is the analysis of mechanism. This analysis of the mechanism includes mobility analysis. It includes the position analysis as well as the analysis of quick return mechanisms, velocity and acceleration analysis, as well as the dynamic analysis of crank slider mechanism. So these are all the topics we'll be seeing in this analysis of the mechanism. Next one is flywheels. Next one is gyroscope, gear and gear trains, cam and follower, balancing of masses, governors and vibrations. Now guys, here out of these 8 topics, the most important ones are analysis of mechanism. No doubt in this we will at least have 1 or 2 questions from this chapter. No doubt in that. Okay. Similarly, the next most important topic is mechanical vibrations. Even from this chapter also we will be definitely seeing questions. Okay. And after that guys, the second most important topic is gear and gear trains. Gear and gear trains. This is the second most important topics. So we'll be seeing more number of questions being repeated from these 3 topics than the other topics. Okay. So after that guys, the remaining topics, that is flywheel, gyroscope, cam and follower and balancing and governors, these are very small topics. and the question being repeated from all these topics, I mean the frequency will be less. But compared to these three topics will be having more questions being repeated. Okay. Now let us try to solve some expected questions, okay, for all these topics. And here guys, we'll be selecting the questions in such a way that we'll not be using the much of calculation. Directly it could be a recall type question or a comprehensive type question or match the following type question. Okay, so we have selected the questions in such a way that you can attempt the question within 1 minute and answer it. Okay. Now guys, this is the first question. The mechanism used in the shaper machine. Okay, shaper machine is actually, guys, let me just draw the diagram for this. It is the inversion of 4-bar mechanism. It is the inversion of 4-bar mechanism. To this link, guys, we will be having the cutting tool attached. Now, if we do the counting here, for this mechanism, this will be link number 1, link number 2, link number 3, piston will be link number 4, this is link number 5, and cutting tool is link number 6. Now guys, here we have a revolute joint, second revolute joint, third revolute joint, as well as there we have a prismatic joint. So far we have identified 3 revolute and 1 prismatic joint. Okay. Similarly, here we will have 1 more revolute joint and 1 more revolute joint. So total we have 5 revolute joints. 1, 2, 3, 4, 5. 5 revolute joints we have and 1 prismatic joint. So guys, here we have 5 revolute joints and 2 prismatic joints. So it is a closed 4-bar chain having 4 revolute joints. No guys, it is not it is a 4-bar chain. Of course, it is the inversion of crank slider mechanism. But in actual, what is used in the shaper machine, it will be consisting of 6-bar chain having 5 revolute joints, guys. It will be 5 revolute joints. Okay, it is not 6 revolute joints. It will be 5 revolute joints. Okay, and even you can try to calculate the degree of freedom. The mobility of this mechanism will be equal to 1, guys. So here we have number of links will be equal to 6, okay, and number of joints here it will be equal to 7, that is 5 revolute and 2 prismatic. 5 revolute and 2 prismatic. Now you can substitute this in the Grubler's equation, that is degree of freedom is equal to 3n minus 1 minus 2j. Okay, so 3 into 6 minus 1 minus 2 into 7, that is 15 minus 14, which is equal to 1. So it is a kinematic mechanism. So option B will be the answer, guys. Okay, option B will be the answer, and it is an inversion of single slider crank mechanism also. Even option D is also an answer. Okay. Moving to the next question. Yes. For a mechanism shown in figure, the mechanical advantage for the given configuration is dash. Now guys, here we can understand this is the input link. This is the input link, and this is the coupler link. Connecting rod will be acting as the coupler link. So when the input link and coupler link are collinear, okay, so the output link will be at its extreme position. Its velocity will be 0. Its velocity will be 0, guys. So here, mechanical advantage, it is given by the formula velocity of input divided by velocity of output. Velocity of input by velocity of output. So input, guys, we are taking here as a crank. Input we are taking as a crank. So that is V crank. And the piston has reached to the extreme position. Okay? Piston has reached to the extreme position. So its velocity will be 0. So at the toggle position, mechanical advantage will be equal to infinite, guys. It will not be 0. It will not be 0 because in crank slider mechanism, we are going to assume the crank as the input link and piston is the output link. But in actual practice, when this crank slider mechanism is assembled in the IC engine, the piston becomes the input link and the crank becomes the output link. Similarly, if you assemble this mechanism in the reciprocating air compressor, crank becomes the input link and piston becomes the output link. This is for the air compressor, guys. But generally speaking, guys, when we are calculating the mechanical advantage, we have to consider the crank as the input link and piston as the output link. Okay, that is the general observation, right? So mechanical advantage will be infinite. And now, guys, this crank slider mechanism is also having an inversion of crank rocker type. Crank rocker type means the input link will be completing circular motion and the output link will be undergoing oscillatory motion. So here oscillatory motion will become, or the locus of the output link will be straight line because it is executing reciprocating motion. Okay, so this is of crank rocker type. So whenever we are dealing with crank rocker type mechanisms, in order to find the extreme position of the output link, we have to make input link and coupler link collinear. Okay. Similarly, guys, here mechanical advantage is equal to infinite. And there could be another position where we can find mechanical advantage as 1, guys. Mechanical advantage as 1. So that is when input link and the output link, or when the crank is at 90 degrees, when the crank is at 90 degrees, for this situation, we will be finding mechanical advantage is equal to 1. Why? Because when the crank is at 90 degree, velocity of the crank and velocity of the piston will be same. So mechanical advantage in that situation will be equal to 1, guys. Okay. So please do remember these two possible configuration. They might ask you a direct question based on this. Okay. Next question. The number of inversions in the crank slider mechanism. In the crank slider mechanism, we have 4 inversions. First one is crank slider mechanism itself, which is used in the IC engine and air compressor. Okay, which is used in the IC engine and air compressor. And air compressor. Now, guys, this is the first inversion. Second inversion we have is, that is, it is used in the radial engine. Radial engine and Whitworth mechanism. Whitworth quick return mechanism. QRM, I am abbreviating it as QRM. Okay. So here the first inversion is crank rocker type. The second inversion is double crank type. And the third inversion is crank rocker type only, but we are going to use that in the crank slotted lever mechanism. Application of that is crank slotted lever mechanism. And other than that, we have oscillating cylinder also. Oscillating cylinder. The last inversion is pendulum pump. Pendulum pump, or we call this as also hand pump. So number of inversions here in crank slider mechanism will be equal to 4. Will be equal to 4. But whereas the double slider mechanism will be consisting of 3 inversions only. The double slider mechanism, it is for double slider mechanism. Okay, 3 is applicable for double slider mechanism. All right. So this is another question, guys. And similarly, if we consider 4-bar mechanism, in the 4-bar mechanism, especially Grashoff's linkage, we will be finding 3 inversions. One is crank or double crank we call. Second one is the crank rocker, and third one is double rocker mechanism. So all these, the 4-bar mechanism will be serving as the fundamental for all these mechanisms. That is for crank slider mechanism as well as for the double slider mechanism. So we are going to recall those inversions over here and then try to correlate them. Right? Similarly, here we are able to find this is a crank rocker, this is a double crank, and this is a crank rocker type inversion, and this is double rocker type inversion. Okay. Next question, guys. This is a double parallelogram mechanism shown in figure. Note that PQ is the single link. This PQ is actually single link, and we are required to find out the mobility of the mechanism. Now, guys, here let us count the number of links. This is link number 1, link number 1, link number 1. This is link number 2, this is link number 3, this is link number 4, link number 5. So total we have 5 number of links. We have total 5 number of links. Now, guys, this will be revolute joint 1. Let us say this as R1. This is revolute joint 2. Let us say this as R2. This will be revolute joint 3. Say this as R3. This is revolute joint 4. Say this as R4. This is revolute joint 5. And this is revolute joint 6. Okay. So number of revolute joints here, that is number of lower pairs, is equal to 6. Now, guys, this is a double parallelogram linkage. If this link number 4, whether this is present or absent, there will be relative motion will be transmitted actually. This link number 4, we can call it as redundant link. This link number 4, we can call it as redundant link, something which is extra. Okay? The presence of those element whose presence or absence does not affect the mobility of the mechanism are called as redundant elements. Okay? So this is redundant link, and adjacent to redundant link we have redundant joint. This is also a redundant joint, and this is also a redundant joint. Okay, so here we have additional parameter, that is redundant link, that is link number 4, and redundant joint adjacent to that we have two redundant joints, that is R3 and R5. R3 and R5. That is equal to 2. Now if you are using the cuts back equation, that is degree of freedom is equal to 3 into n minus 1 minus 2j minus h. If you are using this equation, then guys, you are more likely to commit the mistake. That is 3 into 5 minus 1 minus 2 into 6 it will be. That is 12 minus 12, which is equal to 0. And one of the options is given to you directly. So be careful here. Be careful here. This is not the correct equation what I have written. So here we are required to use modified cuts back equation. Here we are required to use modified cuts back equation. That includes redundant parameters. The parameters which are present or absent, they don't affect the mobility of the mechanism. Mobility means degree of freedom value will not be affected whether this link number 4 is present or absent. Okay, so 3 into n minus nr minus 1 minus 2 times of j minus jr minus h it will be. Minus h it will be. So 3 into n is 5 minus 1 minus 1 minus 2 into j. J is 6. 6 minus 2, and higher pair here as such it is not present. So this will be equal to 9 minus 8, which is equal to 1. Which is equal to 1. So option C is the answer, guys. Option C is the answer. And this parallelogram linkage, it is very easy to analyze also. This is also used in the locomotive wheel. Okay, we'll find a similar kind of mechanism when the two wheels are connected by a coupling rod like this. This is a parallelogram linkage. It can be similarized with the parallelogram linkage. So if I add a wheel in the middle, will it make any difference? No. That the wheel which is added in the middle is link number 4. Okay. So you need to have this understanding. Right? So answer will be equal to 1 for this. So please be careful, guys. 0, you are more like, if you are not able to identify the redundant parameter, then guys, you could have attempted the answer B as the answer. Okay. Next question. A link OB is rotating with constant angular speed of 2 radians per second in the counterclockwise direction, and block is sliding radially outward. So block is sliding outwards with a uniform velocity of 0.75 meter per second with respect to rod as shown in the figure. If OA is equal to 1 meter, the magnitude of absolute acceleration of the block at the location A in meters per second. So guys, here you can see the block is moving with constant velocity. Velocity is constant, that is equal to 0.75 meters. It is constant. Similarly, the link is also rotating with uniform velocity. So omega is also constant, that is 2 radians per second. 2 radians per second. Now guys, here we can calculate radial acceleration. Radial acceleration is equal to OA into omega square. That is, OA is given as the radial position of point A is given as 1 meter and omega is 2 square. This is equal to 4 meter per second square. The radial acceleration will be directed from A towards point O. It will be like this. This will be radial acceleration. This will be the direction of radial acceleration. Similarly, we have to calculate Coriolis component of acceleration. So Coriolis component of acceleration, that is ACR, is equal to 2 into V into omega. That is 2 into V is 0.75 into omega is 2, which is equal to 3 meter per second square. Okay, 3 meter per second square. So for getting the Coriolis component of acceleration, we have to rotate this vector V in the direction of omega by 90 degrees. In the direction of omega by 90 degrees. So this will be the direction of A Coriolis. This will be the direction of A Coriolis. So you can see here radial acceleration as well as Coriolis component of acceleration are perpendicular to each other. And we are required to calculate resultant acceleration. So A resultant that is equal to root over A radial square plus A Coriolis whole square. This is equal to root over 4 square plus 3 square, which is equal to 5 meter per second. So now guys, one thing to observe here is that the questions or numerical type questions, if they are given to you, they will be given in such a way that without using the calculator, you will be able to solve. Okay. So do remember this point also. So easy calculation based questions also can be given. So this question is actually application type. So in this formula guys, we have to substitute the values and get the answer. Okay. Next one guys, for the given statements, meeting spur gear teeth is an example of higher pair. Second option, second statement says that revolute joint is an example of lower pair. Okay. So guys, revolute joint is an example of lower pair. This is a correct statement. But here in the spur gear, we will see that the teeth will be having some sliding action. The teeth will be having some sliding action. And then they will be transmitting the relative motion by the sliding action of the teeth. Okay. And this relative motion will be transmitted at constant velocity ratio. That is the law of gearing. That is the law of gearing. Okay. So here you will be able to see among the teeth there will be sliding action, but still the gear will be regarded as higher pair. Gear will be regarded as higher pair. So here when we are noticing that the relative motion is transmitted at the constant velocity ratio, this actually happens when we are able to see the pitch circles of the gears. These pitch circles will be giving us the information that these two will be executing rolling motion. Rolling motion. So rolling motion will be happening in the higher pair guys. Okay, it will be happening in the higher pair. And we are able to execute this rolling motion by the sliding action of the teeth. And the gear will be regarded as higher pair. Even cam and follower is another example for higher pair. So here I can say both the statement 1 and 2 are correct. Option D is our answer. Okay. Next one. For an Oldham coupling used between two shafts, which among the following statements are correct? So when we are using the Oldham coupling, we are required to select what are the correct statements. So guys, Oldham coupling is used to transfer the power among the shafts which is having parallel misalignment. When the shafts are having parallel misalignment, we are using that. So first statement says that torsional load is transferred along the shaft axis. Correct. Torsional load is transferred along the shaft axis. Second statement says that velocity ratio of 1:2 between the shaft axis is obtained without using the gears. No guys, both are of same size. Statement 2 is incorrect guys. Velocity ratio of 1:1 is transmitted between the shaft axis. It is 1:1 guys. Okay, it is wrong. Bending load is transferred to the transverse shaft axis. Bending load is also transferred guys along with this. Okay, bending load is also transferred. Okay, sorry, bending load is not transferred guys, it is only the twisting load. It is only the twisting load. So statement C is incorrect. Similarly, statement 4 says that rotation is transferred along the shaft axis. So here both torque and the angular speed is transferred along the shaft axis. So I can say here statement 1 and statement 4 are correct. Statement 1 and statement 4 are correct. Okay. Next one guys, number of degree of freedom of 5 bar 5 link planar mechanism with 5 revolute joints as shown in figure guys. So here we have to recall the formula directly. So number of link count is given to us, that is n is equal to 5, and number of joints we can count directly. This is R1, this is R2, this is R3, this is R4, and this is R5. Directly we can count there are 5 revolute joints. So degree of freedom will be equal to, that is 3 into 5 minus 1 minus 2 into 5, that is equal to 12 minus 10, which is equal to 2. Which is equal to 2. So option C will be the answer. And whenever the degree of freedom, if it is greater than 1, degree of freedom, whenever it is greater than 1, we call it as incompletely constrained mechanism. Constrained mechanism, incompletely constrained mechanism. So guys, in order to obtain single input, single output, we are required to give 2 inputs to this mechanism. Okay, that is the physical meaning of degree of freedom. How many number of inputs are required to obtain a single output? So here it will be 2 inputs we are required to give. Okay. This one would be match the following type question guys. So here first one is Scott-Russell mechanism. Okay, Scott-Russell mechanism is actually a straight line mechanism. It is a straight line mechanism. So this will be P4, and Geneva mechanism is used for intermittent motion. Geneva mechanism is used for intermittent motion, that is Q1. Similarly, offset crank slider mechanism. Offset crank slider mechanism, we are using this for quick return motion. We are using this for quick return motion. That is R will be 2 guys. And similarly, Scotch-Yoke mechanism. The displacement equation of Scotch-Yoke mechanism will be written as x is equal to R into R minus R cos theta. So guys, this means that the displacement is a harmonic function guys. It is a harmonic function. So cos term is written. So when that cos term is written, we can say that it is executing simple harmonic motion. Okay. So here I can write S will be 3 guys. S will be 3. Okay. So that is P4, Q1, R2 and S3. That is option C will be the answer. Okay. Next one guys, for an inline crank slider mechanism, length of the crank and connecting rod are 3 meters and 4 meters respectively. At an instant when the connecting rod is perpendicular to the crank, at an instant when the connecting rod is perpendicular to the crank, the velocity of the slider is 1 meter per second, guys. So here the crank slider mechanism is given to us. And the angle between the crank and connecting rod is 90 degrees. This is 3 meters and this is 4 meters. So at this instant, crank is having a velocity of 1 meter per second. Sorry, piston is having the velocity of 1 meter per second. Now guys, here we have to calculate this angle theta, the crank angle theta. Crank angle theta can be calculated. Theta is equal to tan inverse of opposite side. Opposite side will be 4 and adjacent side will be 3. Tan inverse of 1.33, this is equal to, or this will be slightly more than 45. This will be slightly more than 45. So this will be about 53.13 degrees. This will be 53.13 degrees. Now guys, velocity of the piston is given and we are required to calculate velocity of the crank. Omega crank, we are required to solve for it. Okay. So it is given by the formula V is equal to R omega into sine theta plus sine 2 theta divided by 2 times of n. Now guys, V is given to us as 1 meter per second and theta is known to us, that is 53.13, and n guys is equal to L by R, that is length of the connecting rod by length of the crank, that is equal to 4 by 3, which is equal to 1.33. Now we have to substitute all these values in the velocity of piston. We have to substitute all these values in the velocity of piston. So upon substituting those values, so we will be getting omega is equal to 0.267 radians per second, guys. 0.267 radians per second. So here slightly complex numericals you are able to find, but in the examination the numericals will be simplified. Okay. So this is another question, guys, where we are substituting the values in the formula and solving. Okay. So option B is the answer. Next question. So in a crank slider mechanism with crank radius of 200 mm and connecting rod length of 800 mm is shown. Okay guys, here I have missed the diagram. Okay. Is shown the length of the crank is rotating at a 600 rpm speed. Crank is rotating at 600 rpm speed in the counterclockwise direction. In the configuration shown, the crank makes an angle of 90 degrees. It makes an angle of 90 degrees with the line of stroke, and force of 5 kilonewton is acting on the slider. There is a force of 5 kilonewton acting on the slider. Okay, neglecting the inertia forces, the turning movement on the crank is given by dash. Now guys, here in the dynamic analysis especially, we will be drawing the free body diagram of this piston pin and the crank pin, and over that we'll be relating this piston effort with the what we call thrust on the connecting rod, and similarly will be relating that force with the normal pressure on the cylinder walls. Similarly, guys, we will be taking that thrust on the connecting rod and we will be resolving that along the crankshaft and perpendicular to the crankshaft. Okay, so upon doing all those, we'll be able to get the result as tan theta, that is torque is equal to, let us say this is some force Fp. So we'll be getting this as Fp by cos beta. Beta is this angle, guys. And let us say this is theta. So into sine of theta plus beta into r it will be. Now guys, the value of theta is given to us. That is Fp is equal to 5. This is cos beta. And this is sine of 90 plus beta into r is 0.2. Radius of the crank is 0.2, which is already given. So this, upon solving, guys, cos beta and sine of 90 plus beta will be cancelled. So this will be equal to 5 into 0.2, which is equal to 1 kilonewton meter it will be. So option D will be the answer. Okay. Next one, guys, here the cross head velocity in the crank slider mechanism for the position shown is given by. We are required to correlate the velocity of cross head, that is piston only, Generally, we refer this in the steam engine, guys. Okay. We are required to correlate these velocity. Now, here alpha and beta is given. Alpha is the crank angle and beta is the angle of connecting rod made with the line of stroke. So here I will draw a line perpendicular to the crank. So this line is going to make an angle of 90 minus alpha with the horizontal. Similarly, I'll draw a line perpendicular to the connecting rod. Okay, this is perpendicular to the connecting rod and this is going to make an angle of 90 minus beta with the horizontal. And we know very well that piston is going to slide along the line of stroke. So guys, I need to take up these vectors. Piston will be sliding horizontally along the line of stroke. So I need to take up these vectors and then try to build up a polygon. So once that polygon is built, we can write the relations very easily. Okay. So guys, here velocity of the crank will be making an angle of 90 minus alpha. This is V crank. Similarly, this vector I have to take and place it here. This will be velocity of connecting rod. So velocity of connecting rod, this will be making an angle of 90 minus beta with the horizontal. And along this line, along this horizontal line, we can write velocity of the piston. So this is 90 minus alpha, this is 90 minus beta, and this will be alpha plus beta. Now guys, we can apply here sine rule and then deduce the relationship between all these velocities. That is V crank divided by sine of 90 minus beta, it will be V crank divided by sine of 90 minus beta. Similarly, it is equal to V connecting rod divided by sine of 90 minus alpha, it will be. Next one, guys, we have velocity of piston. velocity of piston divided by sine of alpha plus beta. Sine of alpha plus beta. So guys, here Vc is the linear velocity of the crank which is given to us. So you can derive the relationship from here very easily. Velocity of piston is equal to velocity of crank into, this is sine of 90 plus, sine of alpha plus beta. Sine of alpha plus beta can be written as cos of, that is, we can write it as sine will be, that is cos will be positive in the first quadrant. So cos of 90 minus of alpha plus beta into this sine beta will become cosecant, this sine beta will be cos beta, sine of 90 minus beta is cos beta, okay, and this cos beta will go in the numerator, that is secant beta it will be secant beta. So here you can see the relationship, that is sine of, that is we are getting Vc is equal to Vc into cos of 90 plus theta, cos of 90 minus theta it should be, guys. Just a minute. Yes, it should be 9 cos of 90 minus alpha plus beta. This should be negative sign, guys. Here it should be negative sign. Here it should be negative sign. Okay. Cos of 90 minus alpha plus beta is sine beta, sine of alpha plus beta it is. Okay. So option C is the answer. Option C is the answer. Okay. Next question, guys. Which of the following statement is correct? So here, this is again a multiple statement based question. So flywheel reduces the speed fluctuations during the cycle for constant load, but flywheel does not control the mean speed of the engine if the load changes. Yes, flywheel is going to reduce the speed fluctuations for a cycle, during a cycle for constant load, but the flywheel does not control the mean speed of the engine. It has no control over the mean speed of the engine. Yes, mean speed of the engine is controlled by the governor actually. Okay, so statement A is correct, guys. Next, flywheel does not reduce the speed fluctuation. No, guys. Here that is fluctuation in energy is equal to I omega square times of Cs. So here I, that is moment of inertia of the flywheel, and coefficient of fluctuation of speed, they are inversely related. So they are going to control. Okay. So flywheel does not reduce the speed fluctuation during the cycle for a constant load, but it does control the mean speed. No, guys. This mean speed will be controlled by the governor. Statement B is incorrect. Okay. Next, statement C says that governor controls the speed fluctuation during the cycle for the constant load, but the governor does not control. Governor controls the mean speed, guys. It controls the mean speed. Statement C is also incorrect. Okay. Statement D says that governor controls the speed fluctuation during the cycle, and governor also controls the mean speed if the load on engine changes. Guys, here the governor is going to control the fluctuations not within the cycles. It is going to control the fluctuations in cycle. Sorry, it is going to control the fluctuation in speed between two consecutive cycles. Governor controls the fluctuation or speed fluctuations. It is not during a cycle. It is between two cycles. Between two cycles, it is going to control. Okay? But within the cycle, flywheel is going to control. In a single cycle, flywheel will control. Between two cycles, governor will control. So statement D is incorrect, guys. Statement D is incorrect. Okay. Next one, guys. A flywheel is attached to an engine to keep its speed between 100 radians per second to 110 radians per second. If the energy fluctuation in the flywheel between these two speeds is equal to 1.05 kilojoules, then the moment of inertia of the flywheel is dash, guys. So directly, guys, we can use this formula delta Ke max is equal to I into omega max square minus omega minimum square divided by 2 it will be. This is equal to 1.05 and I is not known. Omega is known to us, that is 110 square minus 100 square divided by 2. Now guys, we can solve this question easily even without using the calculator. So I is equal to 2 into 1.05 kilojoules can be written as 1050, okay, and this is 110 square minus 100 square. Guys, we can write this as 110 plus 100, and next we can write it as 110 minus 100. So this will be 210. This will be 210. This is 105 tens. This is 105 twos. 105 twos is 210. And this is 10 ones and 10 ones. This 2 and 2 will be cancelled. This will be equal to 1 kg meter square. This will be equal to 1 kg meter square. That is option B is the answer, guys. Option B is the answer. Okay. Pause करो.
ACE Online. Learn anywhere, anytime. Wherever may be your present journey, but if you decided for your goal, whatever may be your present position, but if you opted to reach higher altitudes in the life, however may be your present duties, but if you choose to find the joy of working, whatever may be your present circumstances, but if you determined for your success. Yes, you rightly heard it. ACE Online platform raises you much more than what you can think. This platform provides pre-recorded and online lectures which you can access around the clock. You can prepare for the various competitive exams like a GATE, ESC, PSUs and other state service exams, mainly in the English, Hindi and Telugu languages. Hope you're all going to make ACE Online platform as a part of your success story. ACE Online. Learn anywhere, anytime. Wherever may be your present journey, but if you decided for your goal, whatever may be your present position, but if you opted to reach higher altitudes in the life, however may be your present duties, but if you choose to find the joy of working, whatever may be your present circumstances, but if you determined for your success. Yes, you rightly heard it. ACE Online platform raises you much more than what you can think. This platform provides pre-recorded and online lectures which you can access around the clock.
Next question, guys, we have is Spur gears from the Spur gears chapter. So in Spur gear having involute teeth, the product of circular pitch and diametrical pitch. Guys, this is a very famous question. Many times in many of the public examination, it was repeatedly asked. It was repeatedly asked, okay? So here, the circular pitch that is given by PC is equal to pi times the module, okay? And diametrical pitch, actually diametrical pitch we are using in the foot-pound system, and this is given by PD is equal to, that is number of teeth per inch we do the designation, that is T by D, and this is pi D by T. So if we multiply these two, that is PC into PD is equal to pi, guys. So the value of pi will be equal to 3.14. Option B is the answer, guys. This is also a recall type question. Okay. Next one. Tooth interference in the external involute spur gear can be reduced. Guys, the methods for reducing the interference, one of them is increasing the center distance, or you can say increasing pressure angle also. Increasing pressure angle. This is one of the methods. Similarly, the second one is selecting or using cycloidal teeth. Even this is also going to reduce the interference. Okay. Next is stubbing of teeth, reducing the tooth height is called as stubbing of teeth. Okay. Fourth one, guys, by selecting the number of teeth properly, by selecting the number of teeth properly on gear and pinion, and last method, guys, we have is undercutting. Undercutting. This is the least preferred method. This is actually removing the non-involute portion from the teeth. So by doing this undercutting, we are actually compromising the tooth strength. It is least preferred. So first option says that decreasing the center distance. Wrong, guys. It is wrong. It is increasing the center distance. Okay. Option B says that decreasing the module. Decreasing the module means we are increasing the number of teeth. Okay. Next, option C says that decreasing the pressure angle. Even still, this is wrong, guys. Okay. Next, guys, here it says that increasing the number of gear teeth. By selecting the proper number of teeth, we can avoid the interference. Minimum number of teeth, guys, it should be at least 18. In pinion, guys, minimum number of teeth should be 18 or it can be 20. So if it is more than 18, the interference is avoided. If it is less than 18, interference will definitely happen. So option D says that increasing the number of teeth or number of gear teeth. Okay. Next one. Which of the following is used to convert rotatory motion into translatory motion? Okay. So bevel gears, it is used for intersecting shaft axis. The shaft axis which are intersecting, for them we will be using the bevel gears. For them we'll be using the bevel gears. Okay, double helical gears, this is used for the parallel shaft, and worm gears, it is used for high velocity ratio. High velocity ratio, we are using worm gears. Similarly guys, rack and pinion, it is used for converting rotatory into linear motion. Option D is the answer guys. Next one guys is the match the following type. So in the match the following type, first one it says worm gear. Worm gear is used for large speed ratios. Large speed ratios. You can have the reduction from 1:20 to 1:100. 1:20 to 1:100. Speed can be reduced by 20 times to 100 times, or torque can be increased from 1 time to 20 times to almost to 100 times in a single stage. Okay, and it is compatible guys. It is taking very less space, and whenever we want to go for high reduction ratios, then worm gear is more suitable. Next is guys, crossed helical gears. Crossed helical gears is used for non-parallel shafts. Non-parallel shafts. And bevel gears is, crossed helical gears is used for parallel shaft guys. Crossed helical gears is used for parallel shaft. Spur gear is used for the, spur gear is used for the parallel shafts. Okay. And bevel gears is used for non-parallel and intersecting. Non-parallel and intersecting shafts. And cross helical gears are used for non-parallel, non-intersecting, or this we call it as skew gears also guys. Skew gears. Okay, the shaft axis will be non-parallel and non-intersecting. So option C, that is here, if I write the code for this, it will be, that is A4, and next is crossed helical gear is used for non-parallel and non-intersecting. B3 and C2 and D1 will be the code guys. Okay. Next one is, this is the epicyclic gear train given to us. Okay. So we are required to find out the velocity. So the arm OA of an epicyclic gear train shown in figure revolves in counterclockwise about the point O. Okay, with an angular velocity of 4 radians per second. That is, omega of the arm is given as 4 radians per second. 4 radians per second. Both the gears are of same size. The angular speed of velocity of gear C, the angular velocity of gear C is dash if sun gear omega s is fixed. Omega s is fixed. Now guys, here if we notice these two gears are in mesh, we can write the statement, or we can write the gear ratio, that is omega c by omega s is equal to zs by zc. In the epicyclic gear train, we have to express this ratio in terms of relative velocity. We have to take the velocity with respect to arm guys, minus arm. So already we have been habituated to write the gear ratio. It is just that we have to add the arm, omega arm we have to subtract. So now guys, since they are externally geared, so we have to write here negative sign. So C we have to calculate omega C, and omega arm is 4 and omega S is 0 minus omega arm is 4, that is equal to minus 1. That is equal to -1. So now guys, upon solving this, omega c is equal to, that is minus 4 into minus 1 is plus 4. So this will be equal to 8 radians per second. This will be equal to 8 radians per second. Option B is the answer, guys. Option B is the answer. So with this single formula, you can crack the question very easily. No need to go for the tabular method. Just memorize the formula of gear ratio. That C, that is speed of the driver by speed of the driven, is equal to teeth of the driven by teeth of the driver. Instead of writing here speed, you have to take it as relative speed with respect to arm. So with that, you are able to easily solve it. Option B is the answer. Okay. Next one, guys. Consider the following statement concerning centrifugal governor. So this is a question from the governors chapter. So the slope of controlling curve should be less than that of the straight line representing the centripetal force at a speed considered for the stability of the centrifugal governor. Guys, the controlling force should be always dominating over the centripetal force or the centrifugal force. Okay, controlling force should be more, guys. Only then the governor will be stable. That is, d of fc by dr should be less than d of f of r by dr. It should be less, guys. It should not be more. Okay, so slope of controlling curve should be more, guys. So statement 1 is incorrect. Statement 1 is incorrect. Isochronism for the centrifugal governor can be achieved only at the expense of stability. Yes, if we want to achieve the isochronism, then we have to compromise the stability of the governor. How that is happening? Means the stable governor, if we plot for the spring controlled governor, if we plot the graph for the spring controlled governor, this will be one line, this will be another line, and this will be another line. Guys, this will be AR minus B, this will be AR, and this will be AR plus B. This will be the line or controlling curve for unstable governor. Unstable governor. This is isochronous. And this is stable governor. This is stable governor. Okay. Okay, so when we want to make the stable governor to isochronous, then from isochronous it will be going towards unstable region. It will be going towards unstable region. So we have to compromise with the stability. Statement 2 is correct, guys. Statement 2 is correct. When the sleeve of the centrifugal governor reaches to the topmost position, the engine should develop maximum power. Guys, when the sleeve of the governor is reaching to the topmost position means the speed is increased. The speed is increased. Okay, so when the speed is increased, the fly balls will move away from the center. So when the fly balls will be moving away from the center, the throttle valve is going to cut the fuel supply in order that such that it maintains a speed near to mean or optimum speed. Okay, so here it says that when the sleeve of the centrifugal governor reaches the topmost position, engine should develop maximum power. No, guys, engine is not developing the maximum power. It is operating at the maximum speed. But at the maximum speed, it is not compulsory to have the maximum power or maximum efficiency. Okay, so we need to operate the prime mover at the optimum speed or mean speed where we are able to extract the maximum power. Okay, Increasing the speed doesn't mean that the power is increased. So you have to study the speed and power characteristics for various prime movers, and based on that, guys, we'll be doing the controlling. So statement 2 is correct. Statement 3 is incorrect, guys. Okay, so option C is the answer. Next one, guys. A Hartnell has its controlling force F given by F is equal to P plus Q times of R, where R is the radius of the rotation of balls and P and Q are constants. So A, that is option A, says that P is equal to 0 and Q is positive. Okay, so this condition is applicable for isochronous, guys. That is F is equal to Q times of R. This is for isochronous. This is for isochronous. The governor is between stable and unstable region. If P is positive and Q is 0, which means that the controlling force will be a line like this, guys. The controlling force will be a horizontal line like this with respect to R. And if it says that P is negative and Q is positive, this is for stable governor. This is for stable governor. P should be negative, negative y-intercept. And next, P is positive and Q is also positive. This is for unstable governor. It is for unstable governor. Okay, so governor has the controlling force, that is when the radius, yes. So here it is always desirable that P should be negative and Q should be positive. So option C is the answer, guys. We want the governor to be stable. Okay, option C is the answer. Next one, guys, the choice of displacement diagram during the rise or return of the cam and follower, rise and return of the follower of cam follower mechanism is based on dynamic condition. For high speed cam follower mechanism, the most suitable displacement of the follower is dash. Now, guys, you need to memorize this equation or the chronological order of velocity. That is, velocity of cycloidal motion is equal to velocity of uniform acceleration. Uniform acceleration. This is greater than velocity of SHM. This is greater than velocity of V is equal to constant, uniform velocity. So here, guys, the equation will be 2h omega by phi a, and this will be also 2h omega by phi a, and simple harmonic motion, it is pi h omega by 2 times of phi a, and this will be h omega by phi a. Please remember this equation, guys. And now, when we are using the high speed cam and follower, it is recommended either the answer could be V cycloid or uniform acceleration. But guys, in this cycloidal motion, we will have finite jerk at all the instances. We will have finite jerk. For cycloidal motion, we will have finite jerk at all instances. But whereas in simple harmonic and uniform motion or with constant velocity, here we will be having infinite jerk, guys. In these two situations, we'll be having infinite jerk. And guys, in parabolic motion and uniform motion, this is the worst kind of motion. Here we are getting infinite jerk more than 2 times. Infinite jerk. maximum times, I should say, because generally we will be having infinite jerk in a what you call in a stroke we'll be having 2 times, but here we are getting 3 times. So infinite jerk, maximum number of times, I should say, right? Number of times, or here it is actually you can say 3 times also. So comparative study if we do, then it will be maximum number of times. Maximum number of times. Okay. So here we are going to prefer cycloidal motion only because we want the jerk to be finite. Okay. So please remember this chronological order of the velocity and it will be very helpful to you. This is 2, this is 2, this is pi by 2 means 1.5 and this is 1. The coefficient of h omega by phi a. Okay. Next one guys is consider the following statements. Cam and followers are generally classified according to the nature of motion, motion of follower. There are 4 kinds of motion: uniform velocity, uniform acceleration, simple harmonic motion and cycloidal motion. Okay. Nature of surface contact with the cam. So we have here knife edge follower, roller follower, flat faced follower and mushroom follower. Even statement 2 is also correct. Next, statement 3, it says that speed of the cam. Yes. Based on this speed equation, we can identify. Okay. Based on this speed equation, we can identify. That is what we call, where we can classify the cam and follower, guys. We can classify cam and follower. So even the statement 3 is also correct, guys. So option A is the answer. Option A is the answer. Okay. Next one. If the axis of rolling of ship and stabilizing the rotor are parallel, it will result in dash. This is in gyroscope, guys. Gyroscope. In this we have I is equal to omega p cross omega s. So if the spin axis and precession axis are parallel, that is cross product of 2 parallel vectors is 0, guys. Cross product of the 2 parallel vectors is 0. So gyroscope will be 0 because spin axis and precession axis are parallel. So option D is the answer, guys. Option D is the answer. Okay. Next one, guys. Air cruising at a speed of 360 kmph takes a turn to the right. An arc of 100-meter radius. Velocity of the aeroplane is 360 kmph. And radius is given as, that is 100 meters. Radius is given as 100 meters. Turbine and propellers have the total mass, that is mass is equal to 500 kgs. Mass is equal to 500 kgs. With radius of gyration, that is 25 centimeters. Radius of gyration is 25 centimeters. The engine rotates at 2000 rpm. That is velocity of spin, guys. That is equal to 2000 rpm. The magnitude of gyroscope is dash, guys. Magnitude of gyroscope is dash. So here, guys, gyroscope is given by the formula C is equal to I into omega times of omega p. So I will be equal to mk square, guys. That is mk square, and omega will be 2 pi n by 60, and omega p will be v by r, guys. Okay. Mass is given as 500. into, this is 25, 25 means it is 0.25, 0.25 meters, 0.25 means it is 1 by 4, 1 by 4 is 1 by 16 guys, it will be. And this will be 2 pi into 2000 by 60. And we can convert this 360 kmph into meters per second guys. That is 360 into 1000 divided by 3600. So that is 360 into 1000 divided by 3600. This is equal to, this will be equal to 360 ones, and this will be tens, and this will be hundreds. So 100 and V by R, that is 100 by 100. 100 by 100. So this will be about 200 guys. 200, and this will be 200 into 500. 200 into 500 by 16, the answer will be approximately. Gyroscopic couple will be, that is C is equal to 200 into 500 divided by 16 guys. So this will be equal to 10 power 5 by 16. 10 power 5 by 16 means approximately guys, this will be 6.55 kilonewton meter guys. 6.55. 16 6 are 96 it is. So 16 approximately will be getting this as 6.55 kilonewton per meter, or maybe option B could be the answer guys. Okay. Next one guys. Which of the following statement is correct? If the rotor is statically balanced, it is also dynamically balanced. It is also dynamically balanced. Guys, here when we are balancing the rotors, first is that if we make the summation of forces is equal to 0, that is called as static balancing. That is called as static balancing. But guys, we cannot say when the static balancing is done, the system is dynamically balanced. We cannot make the claim. We cannot make the claim. Next, if the rotor is dynamically balanced, it must be statically balanced also. In dynamically balanced, if we consider some shaft, on this shaft guys, if we are having some rotors, okay, we'll be adding the masses diametrically opposite to each other in single plane or in different planes. Similarly, parallel or these two masses together will produce a couple in the clockwise sense. We will be adding the counter masses in the different planes, and these two masses will be producing the couple in the counterclockwise sense. So guys, in this system, sigma F will be equal to 0 because masses are added diametrically opposite to each other and movements are also getting balanced. So when the dynamic balancing is done, you can also make a claim that system is also statically balanced. So option B, that is statement 2 is correct. If the rotor is dynamically balanced, then it must be statically balanced also. What does the statement 3 says? If the rotor is dynamically balanced, it may or may not statically balanced. No guys, it is incorrect. Okay. Statement 4 says that if the rotor is statically balanced, then it may or may not be dynamically balanced. It may or may not be dynamically balanced. So we can make a claim that it may or may not be. So the statement 2 and 4 are correct guys. Statement 2 and 4 are correct. Okay. So this is another kind of question guys. Right. Next one. In case of partial balancing of single cylinder reciprocating engine, what is the primary disturbing force along the line of stroke? Now guys, in the crank slider mechanism, we are going to balance this crank slider mechanism by placing a counter mass capital B at a radius of B. Okay, this is R and this is M, guys. So here, if we are trying to balance the reciprocating masses fully, we are actually changing the direction of unbalanced force. It is not getting fully balanced. So we should never try to balance the reciprocating masses fully. Instead, the reciprocating masses are balanced partially. That is, BB is equal to C times of MR. So along the line of stroke, this will be BB omega square cos theta. If this is theta, this will be also MR omega square times of cos theta. So along the line of stroke, we have that is summation of x is equal to, that is MR omega square times of cos theta minus BB omega square times of cos theta. This we can write it as MR omega square can be written as C times of MR. So this, if we simplify, this will be 1 minus C times of MR omega square cos theta. It will be 1 minus C times of MR omega square cos theta. Similarly, guys, we will have the force perpendicular to line of stroke, which is BB omega square times of sin theta it will be. But there will be no force because of the M, guys, because we are resolving that primary force by representing it with mass M at a radius R acting at an angle theta. Okay, so there will be only one force along the that is along the direction which is perpendicular to the line of stroke. So sigma Fy is equal to, that is C times of MR omega square sin theta. This will be the force perpendicular to the line of stroke. Okay, so in the statement it is asking only the force which is along the line of stroke. So that is 1 minus C times of MR omega square cos theta. Okay, so option C is the answer, guys. Option C is the answer. Okay. Next, guys, this is the question from the vibrations. So a vibrating machine is isolated from the floor using springs. If the ratio of excitation frequency of vibration of machine to the natural frequency of the machine is equal to 0.5, then the transmissibility is equal to dash. If the ratio of excitation frequency, that is omega, to the natural frequency of the machine, that is omega n, is equal to 0.5, then the transmissibility ratio is dash. Guys, here damping is ignored, so zeta you can make it as 0. Transmissibility ratio is given by the formula Tr is equal to root over 1 plus 2 times of zeta r whole square by root over 1 minus r square whole square plus 2 zeta r whole square. Anyways, guys, zeta is 0, so this term will be cancelled and this term will be cancelled. We'll be left out with 1 by 1 minus r square. So this will be equal to 1 by 1 minus 0.5 square, guys. 0.5 square. So this will be equal to 1 by 1 minus 1 by 4 is 3 by 4. So this will be equal to 4 by 3, guys. Transmissibility ratio is greater than 1 because we are operating in the region which is below natural frequency. So transmissibility ratio will be greater than 1. So we will see here when we are operating below the natural frequency, then there will be disturbance transmitted to the foundation. That is, force transmitted to the foundation will be greater than the force applied. Force applied. Okay. So option C is the answer, guys. Option C is the answer. Okay. Next one, for an underdamped harmonic oscillator, resonance. Resonance will occur when the excitation frequency is equal to the natural frequency of the system. It occurs when the excitation frequency is greater than the undamped natural frequency. Undamped natural frequency means it is the safe operation, guys. It is safe actually. It is safe. Okay. It occurs when the excitation frequency is less than the undamped natural frequency. Undamped natural frequency means this is partially safe, guys, and it occurs when the excitation frequency is equal to undamped natural frequency. So at this point we will be able to see the resonance phenomena, and at the resonance the force transmitted to the foundation will be very large and the amplitude of displacement will be also very large. Okay, so state option C is the answer, guys. Option C is the answer. Next one, guys, is critical damping. Critical damping is actually, guys, it is the standard definition. It is the minimum amount of damping for which there will be no oscillations. So if we draw the response graph, so for critical damping, the system will reach to rest. This is for critical damping. And for over damping, guys, it may take some time. Over damping. But whereas for the under damping, guys, this is going to have some oscillations. This is called as under damping. So here it says that it is the smallest amount of damping for which there is no oscillations in the free vibration. That is called as critical damping. The largest amount of damping for which there is no oscillation means that is the definition for over damping. That is the definition of over damping. Next is largest amount of damping for which the motion is simple harmonic in the free vibration. No, guys, this is not correct. Smallest amount of damping for which the motion is simple harmonic in free vibration. This is called as under damping, guys. This is called as under damping. So as per the question, guys, statement B or option B is the answer. Okay. Next, guys, in the vibration isolation, which of the following statement is not correct regarding the transmissibility? Guys, for this we need to memorize the transmissibility graph. Transmissibility graph. This is a very, very important graph. This is 1, guys, and this is root 2, that is r is equal to root 2, and this is r is equal to 1. Now, guys, here in this graph, we'll be able to see the transmissibility ratio is increasing to infinite, and then once again it is coming back to 1 at root 2, again it is decreasing. Okay. Similarly, guys, for different values, it is going like this. So please remember, guys, in this direction, zeta and zeta is increasing, guys. Zeta increases in this direction. Okay, zeta is increasing in both the direction. But whereas after root 2, the zeta will be increasing in this direction. Zeta will be increasing in this direction. Okay, after root 2 onwards. Now let us see the statements here. First statement says that transmissibility is nearly unity at the small excitation frequency. At all the values, if r is equal to 0, small excitation frequencies, all the values will be starting from 1 onwards only. Statement A is correct, guys. For all the values, for if R is very less than 1, guys, if R is very less than 1, then we can say transmissibility ratio is almost equal to 1. It is almost equal to 1. It can be reduced by higher damping at any excitation. Now guys, this transmissibility can be reduced by using the higher values of damping at any excitation. Here you can see the behavior of zeta, that is damping, is changing, guys. After root 2 onwards, if we are increasing the damping, transmissibility is also increasing. Transmissibility is also increasing. So after R equal to root 2, increasing damping causes disturbance, guys. Causes disturbance. So this is not at all recommended. This is not at all recommended. Statement B is incorrect, guys. Statement B is incorrect. Now guys, statement C, T is unity at frequency ratio of root 2. Now guys, for checking this, what you can do is, in this formula you can substitute R equal to root 2. You will be definitely getting the transmissibility ratio as equal to 1, guys. For all the values of zeta at R equal to root 2, transmissibility ratio will be equal to 1, guys. It will be equal to 1. Next is transmissibility is infinite at the resonance. So at the infinite, at the transmissibility ratio will be infinite when we are operating near the natural frequency. So this is a dangerous situation. So option D is also correct. Now guys, in the question, which of the following statement is not correct? So option B is not the correct statement. Okay. Option B is not the correct statement. All right, guys. Let us take the next question. The spring mass system, mass M and the stiffness and the spring constant is K. The critical damping coefficient of the system is 0.1. So that is critical damping is 0.1 kg per second, it seems, for mass M and stiffness K. Another system having mass 2m and spring constant as 2k, 8k. Mass is 2 times of m and spring constant is 8 times of k. Guys, critical damping is actually given by 2 times of root over m times of k, guys. So here, that is what we call here, that is Cc is equal to 0.1, this is equal to 2 root mk. So root mk, this will be equal to, root mk will be equal to 0.05, guys. 0.05. We are considering another system whose mass is 2m and stiffness is 8 times of k. So for this, guys, if we consider the critical damping, that is 2 times of, that is 2m into 8k. This will be 2 into 8 to 16. 16, that is 16 under root is 4. So into 4, that is root mk. Root mk, that is 2 4s are 8, and this will be 0.05. 0.05 means this will be equal to 1 by 20, guys. This will be equal to 1 by 20. So 1 by 20 means this will be equal to 20 once, and this is 20 into 0.4 times. So 0.4 kg per second. Kg per second will be the damping value. This will be the damping value if we are increasing the mass 2 times and stiffness by 8 times. Okay. So this would be the last question, guys. Which of the following statements are true for the damped vibration? For the system having critical damping, the value of damping ratio is unity and it does not undergo vibratory motion. Yes, zeta value will be equal to 1 for critical damping. Statement A is correct, guys. Statement B is correct. Next, logarithmic decrement is used to find out the amount of damping. Yes, this is one of the methods to find out the zeta value. Okay. Next, in case of damping, due to dry friction between the moving surfaces, a resisting force of constant magnitudes acts opposite to the relative motion. That is, friction is going to oppose the motion. So friction will be proportional to velocity or opposite to the direction of velocity. Yes, even the statement R is also correct. Next, guys, for the case of viscous damping, drag force is proportional to the square of velocity. Guys, in the Newton's law of viscosity, you have studied this. Tau is equal to mu into dou u by dou y. And we can write this as mu into velocity by h. So if I multiply this tau with some area, and this can be represented with some force Fd, and this can be represented as mu into V by h into area. This Fd, guys, it is proportional to velocity, guys, not square of the velocity. It is proportional to velocity, not the square of the velocity. So out of these, guys, the correct statements are PQR only, not S, guys, not S. Okay. So option C will be the answer, guys. Okay. So these are the few questions which I have discussed, and similar to this only, you can find the questions in the previous papers as well as in the coming examinations. Okay, guys, all the best for your exam.